One of the applications of determinants is using matrix determinant to find the area of a triangle. The way you're going to do it is you're going to take the 3 points of the triangle on the coordinate plane, plug them into a matrix as x1, y1, x2, y2, and x3, y3. And then our last column is going to be 1s. Once you substitute in all the points, you're going to take that matrix and do 1/2 of the determinant to find the area. So pretty simple, just like we did before. You're going to want to copy the first two columns. So when you copy the first two columns, you're going to copy them on the outside. Do your 0 and your 0, 1.9, 0.4, 1.4, and 2.0. Then you'll multiply the main diagonal, your secondary diagonal, your last diagonal. Add those together and then subtract the product of the others. So you're going to do these guys minus these minus these. You're going to get your determinant, and you do 1/2 of your determinant to find the area. You can also use this to find if 3 points are collinear. You do the same sort of thing where you plug in the 3 points. You have 1s as your third column, and if you get 0 as the determinant, then that means that 3 points are collinear. Alright, now that you know how to find the determinant, you can use that to find the inverse. So what are you going to do to find an inverse of a 2 by 2? Well, we're going to take the 2 by 2, we're going to find the determinant. So it's going to be -3 times +3 minus the product of the other diagonal. So you get -9, and then minus -6. Because you plus 6, you get -3. We find the determinant. As long as it's not 0, you can find the inverse for our matrix. Once we have a determinant, now we're going to take the matrix. We're going to switch the numbers in the main diagonal. So our main diagonal is the one that starts there with A11. We'll switch those numbers around. And then for the other two, we're not going to switch where they are, we're just going to change their signs. So that becomes a -6, that becomes a +1. So switch the main diagonal, the other diagonal you're going to change the signs, and then you're going to multiply through by 1 over the determinant. So this becomes a scalar, so then we're going to multiply every element in the matrix by that scalar. So you have -1/3 times 3 is -1, -6 times -1/3 is a +2, and we have -1/3 and a +1. So this here would be the inverse matrix of the one we started with. So one more time, we're going to start with our matrix. We're going to find the determinant of matrix A, which is going to be the product of the main diagonal minus the product of the other diagonal, which gives me 2. So we have 8 minus 3 times 2 is 6, which gives me 2. So we're going to take our matrix, we switch the numbers in the main diagonal, then the other diagonal just gets their signs changed. Then we're going to multiply through by 1 over the determinant. So we get a 1, a -1, -3/2, +2. So that would be your A inverse. Alright, one last thing you can use matrices for is for encoding and decoding. So basically you start out with a coding matrix. So notice we chose a 2 by 2. And then you take whatever you're trying to code and you either assign numbers to it or actually use numbers. In this case, we're using a credit card. So notice the credit card number 4173, 1, 2, 3, 4, and then we wrap around to the next row for the next parts so that it's something we can multiply by our 2 by 2 matrix. Once we get that whole matrix in place, we're going to take the coding matrix, multiply it by the matrix of the credit card number, and we get this new matrix. So this is our coded matrix. So nobody knows what that means right now. So with the coding, what you would need to do is take and multiply the coded matrix by the inverse of the matrix you started with to code it. So there was our original. We want to do the inverse of that multiplied by the coded matrix to give us back what we started with. So you would need to know the coding matrix in order to decode something. So inverse, so we would do the 10 minus negative 3, which would be plus 3, which is 1 over 13. Multiply that by the 5, 2, positive 1, negative 3. And that would be our inverse matrix for the coding, so that'd be our C inverse. And then you're going to multiply that by this coded, and you should get this last thing here, which is actually the credit card number. So just another application.